Hey scholars, welcome to chapter 10, taking a look at sustaining terrestrial biodiversity, but instead of taking the organism or the species approach, we're looking more over the ecosystem approach, trying to preserve the ecosystem as a whole, and how are we going to do that. And so that's what we're going to take a look at today. But first, let's take a look at our case study, and it does have to do with one specific species, the gray wolf, but really looking at the habitat we're reintroducing it to, in this case, Yellowstone National Park. And the background of the story is, around 1800, it says at least 350,000 gray wolves roamed over 48 states except Hawaii and Alaska, and they roamed freely. About 1850 to 1900, though, that wolf pack or that group of gray wolves had declined drastically because of human activity over hunting. People feared wolves. They wanted to use their coats. A number of different reasons. And in 1973, the U.S. Endangered Species Act, they were put under that act, and that kind of separated them and kind of helped them regain their populations overall. In 1995-96, the wolf population tried to do some relocating to help out local extinction, and one of those places that they used to roam widely was Yellowstone National Park in the areas of Montana and Wyoming and Utah, places like that. And so they actually relocated a couple of different packs back to Yellowstone National Park. It did have quite a bit of an ecosystem impact, and we'll talk a little about that throughout the course of this chapter. But in 2008, officials decided to take the gray wolf off of the Endangered Species Act in the states of Montana, Wyoming, and Utah. And while the groups, the packs of wolves that stay inside the park will be protected because they're under national park lands, if they travel outside the park, they are fair game to hunting, which is kind of a sad story. So there's a lot of people lobbying against this because they just reintroduced them to the wild. They want them to repopulate, but people are concerned about their cattle and things like that. So a couple of different sides to the story, but that's what we're going to take a look at, the gray wolf, kind of throughout this chapter, and we'll talk a little bit more about it in class as well. So what are the major threats to forest ecosystems? And one of those major, and we're going to look at a couple of those different threats that we're posing to forest ecosystems, and all the different types of forests, well, not just tropical forests, but also temperate and coniferous and all that other good stuff too. So let's take a look at forests for a second. Forests vary in their makeup of age, how old that forest is, their origins, where they started from. And if you think about it, we have 36% of the world's forests are what we call primary forests or old growth forests. They've been there, they've been untouched by human hands, which is a good thing. And then we also have 60% of the world's forests are second growth forests, where they've been tampered either by forest fire, by human means, cutting them down, building things, then the building's taken down, let the forest grow back. One type of secondary succession. Tree plantations, tree farms, or commercial farms make up 4% of the world's forests, and they actually supply most of our industrial wood, or they may supply, most of our industrial wood for the future if we can do it sustainably and trying to grow trees properly. And this is just a picture of old growth forests, and these are coniferous forests, and these are redwoods, and these are old growth tropical forests down in the tropics. So we're going to take a look at how should we sustainably do some tree plantations and monoculturing of trees. And this is the sustainable way of doing it overall. One of the ways that we'll start with is we plant seeds, all right? We plant the seeds of those trees. Those seedlings are growing. At about the 5-year mark, we're taking a look at about 15 years, we're actually going to take a look and remove old trees or weaker trees that really won't grow to kind of cull the crop of trees, basically, allow those other ones to really thrive. And then we let them grow to about 25 years. Then some areas are clear cut, and then they're replanted again. Now, we would never want to do this on one plot of land and a huge plot of land. You want to kind of rotate through. So maybe one plot of land, maybe a 1-acre plot would be cut, this year, and so they all be on different cycles. So there's different generations growing at a larger plot of land. The reason why is because if you just clear cut all these every 30 years, and you did this on a regular basis, and you did it for all the land, then where would those organisms won't be able to adapt to just no more forest. So it's nice to have kind of a gradual change per acre and kind of change it up per acre that way. All right, let's take a look at forests provide important economic and ecological services. We talked about this previously. Let's review it again. They support energy flow and nutrient and chemical cycling. They definitely reduce soil erosion, which we talked about in chapter 14 with mudslides. Their roots hold that soil in place. They absorb and release water, purify the water in the air. They influence local and regional climates by either blocking wind or slowing wind currents. They store atmospheric carbon, so they're great biological carbon sinks, and they provide beautiful habitats and many habitats for organisms. Now, the economic services that they provide for us are wood for fuel sources, lumber for building houses and products, pulp to make paper, mining areas. They're good for mining. They have lots of minerals in the soil because of depending on the forest. Livestock grazing, if we're letting them roam inside the forest, recreation, employment, all those things provide good economic services that forests help us out with. And so there's just kind of both, there's just a pictorial format of it. I'm not going to go over all those again, but on the left side are the ecological services, on the right side are the economic services. So science focus, putting a price tag on nature's ecological services. If we're able to put money values to all those services, ecological services that forests do for us, they would be worth $4.7 trillion per year. And this is kind of how it breaks out in billions of dollars, what each is worth. Obviously, nutrient cycle worth the most because it is a very much an important part of keeping our Earth, a closed system and one that is sustaining itself. Climatic regulation, raw materials kind of are the next two highest, and then going from erosion control, waste treatment, and recreation being our last. So unsustainable logging, though, is a major threat to forest ecosystems. If we do it unsustainably, we're increasing erosion, which has more sediment running off into waterways. This tampers our water sources. Habitat fragmentation, which some organisms cannot handle properly. They find a hard time. They have large migratory patterns through forests. And if that's the case, then they're going to be really impacted by habitat fragmentation. And that could lead to loss of biodiversity. We've also had major threats by invasion of species, non-native pests, diseases, different wildlife species that are invaders and also invasive. Major tree harvest methods. There's three major ones that we'll talk about. The first one is selective cutting. Second one is clear cutting. And the third one is strip cutting. And we're going to take a look closer at this. But before we do this, you can see how building roads into previously inaccessible forests has kind of impacted this. We talked about this last chapter a little bit in chapter 9. How when you build a roadway, about 37 feet on either side of that roadway ends up becoming depleted or gone in the next 10 to 15 years. We talked about a case study on that. So kind of a scary thought, but you can see how it does. New highways built, cleared out, and then within years, we have that makes access for people to get to, and that's a bad thing as far as forest depletion anyway. Let's take a look at our three major tree harvesting methods. One of those is selective cutting at the top, clear cutting, and strip cutting, and we're going to kind of hit these in stride today. So selective cutting is literally where you are looking at taking out a certain diameter of trees. Maybe you're looking for between 12 to 13 inch at breast height. That's how you measure trees at chest level, and you're looking at the width and diameter of those trees. So that might be one way of doing it. Maybe you're looking at selectively cutting larger trees or smaller trees. Just depends on what you're trying to do with those trees. And you're always leaving a buffer zone kind of intact along the river or the slope there, so that way in case some of that runoff does come from the lack of trees, that it's caught by that buffer zone so it does not enter your stream so your stream ends up becoming clear. Now, clear cutting is probably the worst of them all. It's literally where you are clear cutting a large plot, and you never want to cut a large plot on a slope because that's going to lead to more runoff, maybe even mudslides, which we talked about in chapter 14. So clear cutting is literally where you're taking all the trees from that area and most likely leaving no buffer zone. Even if you did leave a buffer zone, I don't know how good it would work because of the fact that all this is going to be coming down at one time, or at least in slow amounts, but still it's a lot for a buffer zone to take. And the last one is strip cutting, literally cutting by the years. I think this is a relatively decent method as far as sustainability goes. You might clear cut one strip and then replant, and then the next year cut another strip and then replant and so forth. So you're leaving leaving a lot of forest maintained because you're only cutting in strips, but remember you're leaving a corridor where those organisms have to travel, which can be dangerous for those organisms. So you always do leave a buffer zone, again, having that clear stream because you're not taking off all the trees that holds in most of the soil and the runoff. So there's all three of them together. Again, probably your most inefficient one and most dangerous to the ecosystem, again, is clear cutting. This is an interesting photo of clear cutting logging in Washington State and looking at the major difference, and you can see the line. It's kind of it's a very unique picture. They've obviously built roads. This leads to taking out trees, and that's definitely exactly what has happened here, where you've clear cut one side and the difference that it just makes in clear cutting, kind of a totally different habitats right there. All right, so let's take a look at some trade-offs of clear cutting. The advantage is obviously, as far as money-wise, you're getting high yields of timber, which makes you lots of money, maximizing your profits in a very short amount of time. You can reforest with fast-growing trees, and it's good for trees that need, especially these that needing full or moderate sunlight. If you have a tree species that likes full sunlight, then it's good because you're taking all of its competition around it. Disadvantage, though, you're reducing biodiversity by a lot. You're destroying habitat and fragmenting habitats. You're increasing water pollution, flooding, erosion on steep slopes if you're clear cutting on steep slopes, which I highly recommend that you don't do, and then eliminates most of the recreational value. No one wants to hang out in just a bunch of stumps. That's kind of weird. So other things that might impact are fires, insects, and climatic changes can also have an impact on surface fires, usually burning leaf litter and undergrowth. That's actually a pretty good thing for the most part. We are doing that they're called prescribed burns, which you see the base do a lot here in eastern North Carolina. They may provide food in the form of vegetation that sprouts after the fire, so those new seedlings that deer and rabbits and herbivores can eat. The scary fires, though, are the crown fires, and sometimes surface fires turn into crown fires, which is why a lot of times they selectively cut trees that are smaller growing on base, so that way the fire can't jump from the bottom of the forest all the way up to the top by hitting those trees and letting them jump up to become crown fires. Crown fires is where they literally engulfs the entire tree and the tops of the tree, and they burn extremely hot, they burn whole trees, they kill wildlife, and they also increase soil erosion, which are very dangerous fires. And let's take a look at those right there. So here's a normal surface fire, one that's a prescriber, and people are burning this understory so that way the crown fires don't happen. Because if you have middle-sized trees or growth that's just growing up too high, if they do catch on fire randomly, that's going to put you a more of a risk of crown fires, which look like that, burning the entire tree and the whole tree. All right, so introduction of foreign species and diseases and insects. Those a lot of times they're accidental. Sometimes they're deliberate for reasons unknown. But global warming is another one, too, that has, with rising temperatures, tree areas are more susceptible to diseases. They're under more stress. Usually drier forests, too, and that promotes more fires and more greenhouse gases that are in the atmosphere, kind of keeping that positive feedback loop going of global warming. Here's a couple of the invading non-native species and insects just in the United States alone. Up in the Northwest, excuse me, had a mishap there. All right, back to it again. Sorry about that. The U.S. foreign invasive on the upper, in the Northwest, the white pine blister rust, which is a fungal disease, the pine shoot beetle, the beech bark disease. There's hemlock woolly aldehyde, which is another fungus. Most of those are funguses that are caused by either fungi or bacteria. And sudden oak death. There's lots of other insect species that are invaders as well, especially the Northeast, like the Asian longhorn beetle, as well as the emerald ash borer in Michigan as well. So those are a couple of different types. We have cut down almost half of the world's forests, which is obviously known as deforestation, and tropical forests, especially in Latin America, Indonesia, and Africa, and the boreal forests for timber, especially in Alaska, Canada, Scandinavia, and Russia. And this is some of the stuff that can happen when you do clear cut and degrade forests. Your soil becomes so loss of water. This is also a drought that's happening at the same time, probably, but just a scary scene there. Deforestation decreases soil fertility from erosion, runoff from eroded soils into aquatic systems, premature extinction of species, release of CO2, there's no more trees to hold on to those, acceleration of flooding. So lots of negatives for deforestation. So one of the cases we're going to look at are many cleared forests in the United States have grown back, though, which is a good thing. In 1620 to 1920, our forests were decimated. We used them, we cleared, we were building and constructing, and through the Industrial Revolution. And now a lot of them have grown back through secondary ecological succession. We talk about 60% of our forests are through secondary succession. And a lot of times people have biologically simplified tree plantations, reducing biodiversity, which is a problem as well, because if one of those trees catches a disease, then a lot of them will spread because they're all the same species. So that leaves no more forests, which is kind of a scary thought. So that is another problem with monoculturing. You've heard that with crops as well as trees. Tropical forests are disappearing as well. A majority of the loss since 1950 has happened in tropical forests. Brazil and Indonesia experiencing the most loss. And the role of deforestation, the species extinction, is huge. You know, no forest equals no habitat, equals no resources, equals no species. So it's kind of just all linked together as one. This is an image that shows you a satellite image of the Amazon deforestation between 1975, which is here, to now in 2000. Well, now I should say now, 10 years ago in 2001. How much species habitat fragmentation has happened because of clearing the way for farming as well as people and housing and all sorts of different things. So causes of tropical deforestation are varied in complexity. It can be primarily or secondary, and we'll talk about both those here. The basic or the primary causes are not valuing ecological services, crop and timber exports, government policies, poverty, population growth. But secondary causes are really, those roads, fires, settlers farming, cash crops, cattle ranching, logging, tree plantations. The direct causes, I should say, are secondary causes, and the underlying causes are basic causes. And that brings us to the end of section 9.1. Have a great day.